All right, hello everybody. I hope you are doing well. I'm recording this on Friday, April 3rd, 2020. It is a lovely sunny day outside, so hopefully the weather is nice on the day that you are viewing this. Today we are doing lesson 2.8, transformations of periodic functions. Last class we reviewed what a periodic function was, what they look like, how to graph them, how to read a graph, how to get certain information off of them, like the period, the cycles, amplitude, etc. So today we're going to start moving these graphs around exactly how we moved graphs around with the quadratics. Just a quick hint. Definitely use Desmos to check your answers with these. It's the easiest and most accurate way to check if you're doing things right. So if you're having issues with graphs, definitely go type it in there and see if it matches what you're doing. Okay, so the first thing I want you to do, speaking of Desmos, is go to student.desmos.com and type in this code XJ52ET. And I want you to do slides 1 to 6 only. Don't go past that because it does get into other functions that we do not need to worry about for this course. So what you'll do is you'll be given certain tasks to do with the general equation for sinusoidals or periodic functions, and you're going to see how they move around depending on how we change the numbers in the equations. So definitely pause the video here, go do that, and then come back for the summary. Okay, see you in a bit. Okay, I know each and every one of you did that entire activity and you were enthralled. You do know I can check, right, everybody? So what I hope you saw is what we're going to summarize here. So this is a general equation for a periodic function. It looks scary, but it's not. It's just exactly the same as we had for quadratics. Remember, quadratics was y equals a times x minus h squared plus k. Remember? So this is in the same format. For some reason, we use d and c instead of h and k for periodic functions. So the graph of a periodic function is obtained from the graph of this general equation. And each of these letters will tell us how the parent function, so if we just graph sine x, how it gets stretched and moved around. So if you did that activity, you would see that if we have an a value bigger than 1, it stretches the graph vertically. And if the a is between 0 and 1, so that could be a decimal like 0.5, 0.3, if it could also be a fraction like 3/4 or 1/8. If that's the case, it's going to compress the graph vertically. This is exactly the same as what happens with a quadratic graph when we had the a in front. And just like quadratics, if we have a negative number, the graph gets flipped over the x-axis. This is called a reflection. You can think of putting a mirror along the x-axis and seeing the reflection is what you get. D and C perform exactly like H and K did with quadratics. So if we have a positive number in for D, it would look like x minus 3, for example. And because we're subtracting off of the x value, we're going to move to the left. Okay, if we put in a negative number, so negative 10, for example, it would become x minus negative 10, so that becomes x plus 10. So if this looks like x plus 10, we're going to move to the right. Okay? So for C, it's going to be the same for quadratics. If C is positive, it's going to move the graph up by C units. So if it's 2, it graph moves up by 2. And if it's negative, well, it's going to move down by 2. Again, exactly the same as quadratics. And if you take other courses in the future where you're doing this kind of thing, it's the exact same thing for all other functions. If you're doing a absolute value function, exponential function, anything, if we have these letters in the same places, they're going to behave like this, which is really, really nice. Okay, we're going to do some examples here. And I'm going to give you the answers so that you can see how these things are worked out, and then you're going to have some practice. Okay, so the first group here is we're just going to get some equations and we're going to state the transformations for them. So we look for those 3 numbers, right? We're looking for A, we're looking for something in with X, and we're looking for something on the outside. So this one only has the number at the end. Remember, that's the one that moved the graph up and down. It's negative, so it's going to go down by 2 units. This one only has a number in here. There's no A and there's no C on the outside. Because it's x minus 30, remember it's going to do the opposite that you think it will. So this is going to move right by 30. Okay, because we put a positive number in here to get x minus 30. Okay. This one, we don't have the D, we don't have the C, we only have the A. The A, remember, stretches if it's bigger than 1, so this is going to have a vertical stretch by 3. This one has all 3, including a negative in the front. So remember, the negative is going to flip it over the x-axis. That's called a reflection. The A, this is going to stretch it because it's bigger than 1, right? It's going to stretch it by a factor of 2. We've got negative 120. It's negative. It's going to do the opposite you want it to. It's going to go to the right by 120 degrees. And at the very end, we have the negative 1, which moves it down by 1. So there is the final list of transformations. I do want to see you using these terms, things like reflection, vertical stretch. You can say shifted, you can say transformed or transferred by the right to the right and left, or down, up and down. I do want to note here that notice if you have these degrees in here, well, that's because when we're dealing with sine and cosine, we're usually dealing with degrees, aren't we? So that's why you're seeing angles in these equations. Okay, that also needs to remind you to put your calculator in degrees mode. Okay, so that's basically how you can find transformations just from looking at the equation. Well, now we're going to start sketching these, and we're going to state the domain and range. So what I'm going to do here actually is, well, first I'm going to fill in the table. I'm going to make a table of values. Okay, so we're going to do, this is called our parent function. Okay, all of our other periodic functions are based on this guy. We're just adding other numbers to him or her. So I'm going to pick some key points. It's always nice to just do 0, 90, 180, 270, 360. Remember, all around the circle. And then to make my y column, I'm going to do sine of my x value. So if you put in sine of 0 into your calculator, you should get 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360, again, should be 0, which makes sense because 0 and 360 are on the same location on a circle. Now, what about for this one? Well, you could just, oh, I forgot to put the 2 in front. Let me change that. Oh, I have it here. Okay. So just remember, this should say 2 sine x plus 45 plus 2. What you're going to do is you're just going to basically calculate this out by putting in your x value in for x. So for this first one, you're going to go 2 times sine plus sine of 0 plus 45, which is just 45, plus 2. So you should put it into your calculator like 2 times sine of 45 plus 2. Please check that you are getting 3.4 for that answer. Okay? The next one, you're going to do the same thing, except this time for x, you're going to put 90. So 2 times sine of 90 plus 45, this is 135. So 2 times sine of 135 plus 2 gives you 3.4 again. Okay. We're going to do the same with the last 3 angles here. I'm not going to write it out like this, but you just need to know that this time you're going to put your x as 180, and then the next one, the x is going to be 270, and the x is 360. And here are the answers for those. So at 180, our new y is going to be 0.6, 270, 0.6, 360, it's back to 3.4. Okay, so now we have our original graph we can draw, and our second graph, we're going to have the same x values and these y values. So what I'm going to do is I'm going to exit out of here and I'm going to pop over to my iPhone, which is looking at this. Oh, now I got to get back in here, right? Oh boy, I better do my touch screen so you guys don't see my whatever it's called, my password. So let me get this set up. I had it turned off for too long. I'm just going to get this in my stand here. Okay, so I have typed out the solutions here, and now I'm going to graph it. So notice how I have a coordinate grid. This time though, along my x-axis, I'm hoping you can see this. Let's see if I can zoom in a bit. Along my x-axis, you'll see that it's angles. Okay? So I'm going to graph the sine of x equation first. So I'm going to graph this guy first here. So my first point is 0, 0. We'll go over here and put 1 at 0, 0. My next point is 90 and 1. So go back here. 90, and I'm going to make every 2 is 1. Okay? Just so I can use up more of my sheet if I need to. Okay, so sorry. So 90 and 1 was a point, so 90 and 1. And then we go to 180 and 0. And then my next point was 270 and -1. And then 360 and 0. Now, once you have 5 points, you can actually just start repeating the pattern to get a longer graph. So for example, I notice it goes 0, -1, 0, 1, 0, -1, you know, and it kind of goes back and forth. So here I know at 90 it's going to go down to -1, 180 is going to be 0, 270 is going to be +1, and -360 is going to be 0. And now I'm going to draw a nice smooth curve through those dots. Remember, sine curves are nice and smooth. Something like that. Okay, and now we're going to do the same thing for our other ones now. So again, we're going to have the same points, but this time we're going to have our different y values. So at 0, it's going to be 3.4. So 0, 3, that's 3.5 there, so it's going to be fairly close. I'm going to do this in a different color. At 90, it's 3.4 again. So 90 is 3.4, which probably means that this is going to be the top of the curve, right? At 180,